Hi there, I'm Mike Poole. I apologize for the delay. But I think we are finally up and running. I just want everyone to see before I started that I am such a disciple of data center architecture that I actually dressed like Dave McComb today. I put on a blazer and a white shirt, and here to help spread the gospel about making it real for data center architecture. The slide deck or the presentation I was focusing on today is about developing a consortium, and I've created a deck that has a slightly more provocative title. It's called Semantic Silos, Chesterton's Fence, and the Canada Health Act. The focus on this is about consortiums, but I want to kind of set the context for this a little bit to say I think the whole notion of governance within a large organization is particularly central to actually making the whole data-centric approach real, right? So what I wanted to do in this discussion today is briefly talk about what what the whole the motivation and sort of the most important motivators for knowledge graph and semantic technology is, and then consider and discuss, how exactly, why those are important things to do, and how exactly the knowledge graph technology allows us to do that, and then kind of discuss how the role that a consortium can play in that. So just to get started, when we start developing, or when we advertise knowledge graphs, one of the things we often say about the knowledge graphs is, hey, the great thing about a knowledge graph, or the great thing about semantic technology, is that they allow us to get rid of semantic silos or data silos, or they democratize data. And I think that's of course an obvious that is of course what we say about it. But it's useful to stop and pause for a moment and think, why is that useful or important? Why exactly do we want to get rid of data silos or semantic silos? And I think the obvious answers to that are, we want to be able to pull our data together, right? That gives us the advantage of being able to link it and analyze it. We want to be able to access our data more quickly, right? We don't want to go peruse the entire firm and find out who owns what. We just want to get to our data quickly. We want to put it in one place so we can see discrepancies and understand, why exactly it is that, the data is being represented in different ways or looks different. And we want to avoid duplication of effort, right? If some data already exists, we don't want to model it twice, et cetera. So I think, I think most people here, recognize why we want to get rid of data silos. And then I guess the next question is, so why exactly though, and is it the case that semantic technology or knowledge graphs actually lets us, how it actually eliminates the data silos? Like how does that occur? So if we go to the next slide, that's kind of a key question. How is it that we get rid of these data silos? Well, for one thing, we can say, well, we have a graph. So now, because we have a graph, we put all the data in the same place, and we're using the same formats. We're standardizing it by these OWL and RDF standards. So that should get us a long way to eliminating these data silos. But of course, I think most people that are participating in this discussion realize that's not all there is to it, right? So if we take, if we consider, for example, a situation in which one group in the bank has a table of data with a table called person, and they have in there a field for ID, and then one for first name and last name, and a field for their manager. And there's another data set in the bank that has a personnel table, and it has login ID and name and managed by. Now, obviously, for us, it's fairly clear. We look at that and we say, well, look, these are obviously the same. They're talking about the same conceptual concepts. But if we just threw this data into a graph with a very naive kind of transition or ETL process, we'd get that data in there. It would all be using RDF, but it wouldn't be that useful to us. We wouldn't understand. We wouldn't be able to query it directly. We'd have to understand, pull it together. So just putting the data in the graph isn't enough. Similarly, if we had, this is actually a situation I've seen in more than one situation where people will say, okay, I've got a field called country in this one and a field called country in that one, and they'll just pull the data in, and the one field is using the country names and the other field is using the 2-letter ISO codes, And then we'll have a bunch of objects in there. There'll be one that namespace that just has a United States object, another one has a US object. And again, there's been no effort made to link those together to recognize that they're the same object. So point being, again, I'm sure most people here understand this. Point being, just throwing the data in graph isn't enough. You have to do some work to link it together. You have to have some sort of common vocabulary. We want to be able to say, hey, login ID over here and ID over here are the same thing. Here is name, and it's composed of first name and last name. This manager field is managed by field. There's some common concept they have in common, and we want to be able to pull them together. Similarly, we want to map our countries to some kind of model of countries so that we can understand, hey, United States is this thing that contains New York and California and all these other things. So, it's a little bit more work than just throwing the data into the graph. And it's a little more work. It's also a little bit more work than just standardizing a vocabulary, right? Because let's consider here, this is another real example taken from real life. Let's consider the notion of a merger, right? So I work in the financial industry, and a merger is a fairly common concept. So if we look in the next slide, if we can try to figure out what the concept of a merger is, there's actually some competing definitions that exist out there, right? If you go to Investopedia, it gives this definition of a merger. A merger is a situation in which two entities have come together and they both have ceased existing and a new one was created. So, right, Bank of New York and Mellon Bank merged in 2007. Those two entities both ceased existing and a new entity was created. It was called Bank of New York Mellon. That was a brand new entity. It started existing the day that those two other entities ceased existing. But there's another definition of merger in which two companies just joining together to become one is still a merger. What some people might call an acquisition, some people actually call that a merger. So the point being, suppose now that we had said, oh, we're going to create a standard vocabulary. We've got this concept of merger in our ontology, and we have different groups in the bank who had been using the term differently, throw all their data into a knowledge graph and say, I've got a merger here, I've got a merger here. And it turns out we've actually kind of made a little bit of a mess. Like I would say, that's a little bit like when we're trying to consolidate our spice cupboard and we throw the salt and the sugar together because we say, well, they both look to be the same. We just throw it together. The result could be that you actually obfuscate your data more, or you make your data sort of a mess. So obviously again here, the solution here is not just a common vocabulary, but also some semantics, right? We want to be able to articulate what the meaning of a merger is so that when we ingest a new data set, we can say, oh, this thing, you use the word merger, but here's this formal definition. We can run quality checks and determine, hey, it turns out that your definition of merger was not the same one we're using here. We can recognize that. So. Okay, so point being, again, like I said, I don't want to belabor this too much because I think everyone here is convinced of, yes, beyond just having a knowledge graph, we have to have some kind of semantic framework in place. But then the next question is, okay, semantics are great, right? Many people here probably do ontology. We love to formalize these concepts, but how far do we go with it? How far, how rigorous do we have to be about developing a semantic solution to make our knowledge graphs work effectively? And kind of as a straw man proposal here, I pulled up what the Knowledge Graph Foundation suggests as kind of a long-term roadmap strategy, is that ultimately in a knowledge graph environment, you want all your data concepts to be expressed, and I'll just read this directly from it, at their most granular level as mathematical statements in a machine readable form. These things have to have precise semantic structure based on defined business rules and applicable to data at rest and data in motion. I'm going to call this the maximal semantics route, right? It's the suggestion that ultimately we have to have everything formalized and machine readable, and that's where we want to go with our knowledge graph. So that is probably that is a strategy we can have. But before we dive into that a little bit and see what that means practically for knowledge graph development, I want to just pause also and think about this kind of antipathy we all have towards semantic silos, right? We all say semantic silos have to go, and And when we think about that, it's like, yes, there are reasons that we want to get rid of semantic silos for all the reasons I just mentioned. But I think it's worthwhile going back to pull up an old allegory from G.K. Chesterton about the what we people now refer to as Chesterton's fence. So if you can pop the slide up there, I'm just going to read that quote directly. Chesterton once said, he talks about, he disparages this kind of reformer who goes about through a town and finds a fence and says, I don't see the use of this fence, we're going to just throw it away. And he says that, and Jeff Chesterton says, the more intelligent reformer will say, wait, if there's a fence there, we should think about why that fence was there in the first place. Until you've thought about why that fence may have existed, I'm going to be a little bit reluctant to tear it down. So I'm going to just pause and just say, with respect to, we may want to think about data silos about that, with respect to that a little bit. Like, let's think about data silos as a Chesterton's fence. So we've got lots of good reasons to get rid of data silos. If we pop to the next slide, but what are some of the reasons that they existed in the first place? Well, part of the utility of these data silos, or these applications, these applications with all these different models, the one useful purpose that they served was they allow people to model things differently in different contexts, right? We recognize that in a large organization, some people will be using data, the front office in a bank may be using or have a representation of a financial instrument that's different from the one that the back office needs, because they're trying to do different things. One is trying to sell, the other one's trying to reconcile and do different things with it. So it may be perfectly legitimate for them to have different models, and they may have said, well, I don't want to have to spend all my time negotiating with the front office every time I want to change the model. I just want to have my data here, or I don't require the same level of granularity you do with your data, or I don't need it to be updated as frequently, or I don't need as many fields. So it's worthwhile to think about, that's one of the positive features of these existing data silos, is that they just allow kind of localized governance and control. So people can proceed and change their data, and they're able to do what they need with it in their isolated environment. It impedes us from doing what we talked about earlier. It impedes us from being able to pull the data together, but there were some good reasons to have those data silos there in the first place that we probably shouldn't ignore as we're trying to pursue these knowledge graph semantic technology-based solutions. So anyway, point being, when we consider these solutions, we have to remember they're going to need to work in a whole different range of contexts. So I guess I would say we don't want the utility of the semantics to enforce counterproductive homogeneity. And I think Dave talked about this a little bit in his talk earlier this morning, about but the extensibility being kind of a key feature. So when we're being data-centric, it doesn't mean that we try to model everything up at the beginning, but we want to have a core that's extensible. And that's really what I want to kind of emphasize here as well, is to say, don't think that we need to solve everything up front, but instead think about saying, well, we want enough semantics so that things can be extensible, but we don't want to have so much semantics that we enforce this homogeneity so that people can't use our graph. So then kind of going back to that scenario where we're saying, well, what we're really trying to shoot for is kind of this maximal semantics approach. Well, if we're doing that, if we try to do that as kind of as building the foundation upon which our knowledge graph is constructed, it can create some problems, right? If we try to make that the first problem we solve, because obviously, for one thing, it's just a lot of work, right? If we said, okay, well, before we can really make this knowledge graph successful, we have to hire, dozens and dozens of ontologists to build us all these models. It's just a lot of work. It's going to impede things. Secondly, if we have really complicated models, if we've tried to model in anticipation of every single thing, the models are just too restrictive. They're too complicated. ETL becomes too difficult. We'll never get the data onboarded that we wanted to. Let me say something else that's probably somewhat controversial, but I think our knowledge graphs in large organizations have to be flexible enough to allow for not only the fact that we have different needs for the data. It may be the case that we actually need different models, that the conceptual representation is distinct enough that we just need very, very different models. So we do want to just say, in some cases, it's so different that the models are actually different, but we want to be able to find their link points or be able to compare and contrast them or something like that. but that's a, I think a reasonable thing that we may want to expect in the process of developing our knowledge graph. I guess a couple of things. If we try to negotiate all the meaning, that's a very slow process, right? So if you try to figure this all up front to get all our semantics in place, that's just going to impede things. And I guess finally, I would say, there is some utility in retaining some of our legacy systems and understanding them. And sometimes it may be the case that we don't necessarily want to, reform all of that. We may want to just say, well, let's pull that stuff in. So there's some reasons to think, to be a little bit cautious about trying to over formalize or to create to be too aggressive about developing sophisticated, complex semantic models. So really kind of, again, I really kind of appreciate what Dave was saying this morning about how the core of this thing can be relatively small, like a core model. It doesn't have to be, we don't have to represent everything. We want it to be extensible, but not comprehensive in order to start making progress on these kinds of efforts. So when we think about that, so the point being here again is kind of a three bears kind of thing, where we say, we don't want to have too hot, we don't want it to be too cold, but somewhere in the middle, right? We have to have enough semantics so that we can put things together accurately and effectively. And we don't want to be so aggressive about implementing semantic solutions that we impede progress, right? So and we want to allow, hey, different areas of the bank are going to need this. We don't want our model to be so complicated that they can't use it. So the question is, how do we find this middle ground, right? How do we find this middle ground between saying enough semantics, but not too much? And to answer that question, I'm going to flip over to what might seem a very different kind of story, but I think it's one worth considering because there's a similar kind of problem. So if we consider, let's consider a very different kind of problem, the problem of universal healthcare in Canada. So I want to go to the next slide. In Canada, they somewhat famously have universal health care, as we often have heard talked about in the recent elections and what have you. But the Canadian system is interesting because the Canadian system is not a fully centralized model. Every province administers healthcare their own way. They each have their own funding models. They each administer their hospitals in different ways, et cetera. But the Canadian government and the Canadian people we want every citizen in Canada to have, this sort of the same level and quality of care. They want to have the same access. So in some respects, the quality and the nature of the healthcare people receive in Canada has to be more or less equal and, interchangeable almost. And nonetheless, they want to leave all the provinces and territories free to administer their own healthcare system. So in doing that, it's interesting to take a look at what the Canadian government's, the Canadian Health Act actually articulates some principles to realize this. They said each province is free to administer its own health care, right? But while doing that, they have to be guided by these 5 principles. The 5 principles are public administration, and that's regarding funding. There has to be complete transparency in how they're spending their money. There must be reasonable access, right? So you can't just, like in a large province like British Columbia, you can't just have one hospital and expect everyone to come there. Comprehensive, it has to be able to cover, anything's medically necessary. You can't, a province can't decide, well, we're going to save a whole lot of money this year because we're going to stop, funding, bowel cancer or something like that. It has to include everything. It has to be universal. Everyone has to be covered. You don't get to say, well, we're not going to cover people over 85 anymore because that's too expensive, right? So there's these principles in place, and it has to be portable, right? If I'm a resident of British Columbia and I go to Ontario for a vacation, I should be able to access healthcare there and be covered, et cetera. So those are the 5 principles. And I wanted to take that, because you see where I'm going with this analogy, I think that the problem the Canadian government is trying to solve with universal healthcare is not unlike the problem we are trying to solve in a large organization with a knowledge graph. We want our data we want to be able to have some kind of transparency and accessibility with our data. We don't want to have somebody telling, we don't want the HR people telling the quants how they have to model derivatives or something like that, or contracts. So the way we want to solve this, I think, is I wanted to propose kind of an analogous Healthcare Act for knowledge graphs. So if we took those 5 principles from the Canadian Healthcare Act and apply them to the knowledge graph development scenario, what does that look like? So if we go to the next slide, if we translate this into a data scenario, and we said, let's suppose now I think we want some form of that. We want public administration, and that means in the context of semantic technologies, anyone can find out the meaning of concepts. They can find out where the data is. They can find out how it's been transformed. They can find out who is using it, etc. We want accessibility. We want to know where the data is. We want to be able to pull it from different environments into our environment, right? So we make the data, setting aside kind of access control for privacy reasons and what have you. We want to make the data kind of accessible. We want it to be comprehensive, and that's kind of key. We want to make sure that our models are, we haven't modeled something so elaborately or so inconsistently that my model of contract that I'm using over here isn't reusable by the model of contract that people are using, let's say in the UK or something like that. So our models should be comprehensive and general enough that everyone in the bank or in the organization can use them. It should be accessible. The data should be accessible to everyone in a clear manner and portable. So I think that when we often have a knowledge graphs as creating enterprise knowledge graphs, I think it's more useful to imagine a situation where I could have 10 knowledge graphs across the bank or across the organization. This applies anywhere. But the key thing being, in some sense, I have a virtual enterprise knowledge graph insofar as it's relatively easy for me to take the data over in this group's knowledge graph and plug it into mine. That's the kind of thing that when we talk about portability, I think we want. So I think those 5 principles of the Canadian Healthcare Act can be reapplied to knowledge graph, what drives us in knowledge graph development and the deployment of semantic technologies, publicly administrable, comprehensive, portable, et cetera. Those are the kind of things we want. So point being, how much semantics we want? Well, we don't want to create a comprehensive ontology that formalizes everything in the firm, right? That's just as I said, like the Canadian government doesn't indicate how long the emergency room wait has to be in New Brunswick when somebody has the flu. They kind of leave that to the local organizations. But what we do need, I think the key to solving this is having a framework for communication and sharing across all the contexts, right? So if you're building a knowledge graph and I'm building a knowledge graph, I want to at least be able to make it fairly easy for me to find out what you're doing and for you to find out what I'm doing, and for us to share our data across those different scenarios. So I think that's the key. Don't try to be too comprehensive, but do try to be fully transparent and be able to take these to move from one context to the other. So as I said, we're not trying to create a single firm-wide model. We also don't say, okay, guys, the bank has bought a whole bunch of triple store licenses and a bunch of licenses for ontology editors, and distribute them and have at it, and we hope this is all going to work out in the end. But what we try to do is to say, here, you guys have the freedom to kind of build your own semantic solutions, but we're going to have a consortium. And we've very deliberately chosen that word consortium because a consortium it's a group that it's not a governing group. It's a group that brings a number of other groups together, right? That's the notion of a consortium. And what a consortium typically tries to do is it strives for consensus and alignment, right? What we're trying to do is to have, here's a place where all these different groups can come together, discuss things, and try to align and develop consensus. So that's what I think is kind of key to saying, to kind of finding this happy medium between enough semantics so that we get things right, and we don't pave over important semantic differences, and not so much semantics that we can't get any progress. We have this consortium that says, you guys focus on your strengths, we'll focus on our strengths, we'll talk about the commonalities, and we'll provide a forum for doing that. So in the last few minutes, I just want to talk about what does that mean practically? What do we do with the consortium that that allows us to realize some of these objectives of semantic technology and knowledge graph frameworks? So what does this consortium do? What does it do? First of all, it provides a forum for communication, right? And that forum, it can take a number of different forms. You know, the regular meetings. You know, we have chat boards, we have mailing lists, and just just ad hoc meetings from time to time. If we say here's a challenge, somebody over here in the risk group is trying to model, over some people over here may have some opinions how it's done. Let's have an ad hoc meeting. Let's discuss it, and let's try to talk to each other. The key thing, again, kind of what Dave was getting at this morning, we have this notion of a core ontology. That core ontology doesn't comprehensively model everything that we could ever think of across the bank, but it does take key notions like the notion of an employee, the notion of, let's say, a building, the notion of, let's say, a contract, the notion of a piece of software, all these things that are going to be relevant across the bank. We have basic concepts, so we have the glue so that different people modeling these things have something with which they can stick them together. Similarly, for a contract, we don't try in the core ontology to develop a complex model that will cover, a derivative swap. What we do have to try in the core model to have a basic notion of a contract is, it involves two parties. It probably has a start date and an end date, but a core, that's just the key meaning. The other key thing is there's a hub and spoke model for the framework ontology. So what that means is there's this central set of concepts, but the spokes, if you think about, what does a hub and spoke look like? The spoke can be somewhat parallel, right? It allows that could be some development going on of concepts that may not, that may be sort of an in parallel thing. So we can share, we can communicate across the spokes, but similarly, there's some kind of looseness allowed so that you can develop in your spoke, I can develop in my spoke, and we're going to try to talk to each other, but you're kind of free to do that without worrying about violating what I'm doing over in mine. There's a few other practical things. A really good example of some kind of place where we try to reach some kind of consensus has to do with temporal modeling, right? If people know anything about RDF and OWL, there's lots of different ways to represent, how things change over time or show, events or how relationships change. And what we've tried to do is to say, well, let's stop and think about that so that we've kind of identified not necessarily the best way, but kind of a consensual way that we say, okay, well, this is the way we're going to do it. And if you guys do it that way, that's going to make it a lot easier for us to pull our data sets together. So we'll do some thinking of things like that, where this notion of temporality, it's not like any one group has the best idea of how to represent temporality. So we kind of work together on that, maybe create an ad hoc working group that can just sit down and discuss and say, here's the best practices for temporal modeling. You want to go to the next slide? And facilitate ontology sharing. So as I said, there's a hub and spoke model, but if you're developing an ontology in your group and I'm developing an ontology in my group, it should be fairly easy for me to find out what you're modeling and what your models look like. And similarly, you can for mine. We're not trying to develop these models in a hidden away fashion, but we want to make them, that we may have them indexed and shareable and put them in similar kinds of environments so you can get mine, I can get yours, and we can plug and play. One other kind of thing I want to really emphasize, I maybe should have almost put it first, but I think it's really, really important for this consortium to identify standard operating models for IRI minting, because I think that's really a key thing to interoperability. So it may be so what you want to do there is to say, well, look, the way we build our IRIs, it may not be the case that we want to have one group say this is how all IRIs are made, but we do have a standard way to identify the IRI pattern, so that if you're making, creating IRIs for employees that use their login ID, and I'm using the employee ID, ideally we would have a way to say, well, let's pick one. But even if we didn't, we would have enough metadata in place that you could rapidly find out, how did I generate my IRI and how did you generate your IRI, so that we can do identity resolution. And I think finally, one more thing that I would really emphasize here that I think is key to kind of solving some of these interoperability things is I think OWL and Shackle are really nice complementary languages or representational approaches that you can use to your advantage. If we think of OWL as the place where we articulate what stuff really means, and if we think of Shackle, and again, I'm kind of paving over some issues here, but if we think of Shackle as the way to say to pick which elements of meaning we're going to enforce, or to pick or to write more detailed things, like we may want to say something like, social security numbers have to have dashes in them. We can enforce that kind of stuff in Shackle. We say that doesn't have anything to do with meaning, or this has to do with meaning, and this is what we're going to enforce. But you can use Shackle you can use it strategically to say, here's the meaning that this we're going to enforce in this context, here's the meaning we're going to enforce in that context, or here's something that's not really a meaning thing, but I'm going to write a data quality rule over here that gets enforced. And I think that's Shackle and OWL are also like some really good tools to allow you to have shared meaning across the bank or across the organization without having to say everybody's data has to look the same. So anyway, we have lots more things that we could talk about with this, but I think I've used up my 30 minutes, so I would invite you all to join me in the Q&A session and be happy to talk about this some more.